Good morning, students. We're going to start where we left off yesterday, and we were looking at determining the rate of change from a graph. And we start looking at one example, we'll continue with that example, and then we'll make sure that everything um, runs from there. So I'm stumbling over my words. This is actually the fourth time I've started this movie this evening. Let's just go ahead and look at question we were looking at yesterday in class. So we had a water tank on a farm and we know that it holds 6,000 liters. The graph represents the tank being filled at a constant rate. At what rate is the water being stored in the tank? So this is a rate of change problem. So we need to find 2 points on the graph that we can read exactly. So I said yesterday it means that they're in the crosshairs. It does not matter which 2 you take, but take 2. And what we're going to look at for our rate of change, it's the change in our y values over the changes in our x values. So if I look at the coordinate point here, this is an 84,000. This coordinate point is 21,000, where an ordered pair is our independent variable, our dependent variable. Time is our independent, volume is dependent. All right, so if I think about what this represents, this is, let's call this point 2. So this is the x coordinate of point 2, the y coordinate of point 2. This would be the x coordinate of point 1, the y coordinate of point 1. So we're looking at the differences in the y values over the differences in our x values. So we have 4,000, subtract 1,000 over 80, subtract 20, which gives us 3,000 over 60. I said that's 50. 50 what? What does that represent? That's the rate at which the water is being filled, right? The tank is being filled. Well, how fast is it being filled? It is being filled 50. How does that work? Our rate of change is 50 liters per minute because it's our dependent over our independent. I just had to check my um, my labels of my axis there for a second. So 50 liters per minute. This is speed, right? The speed at which it's going. That's what a rate is, a speed. Okay, now let's look at another one. This is it being emptied. So I want you to take a moment, right? Same type of question. We have 60,000 liters. We want to know the rate of change that's being emptied. How fast is water emptied from the tank? Right, so can you please calculate the rate of change for that? I'm going to take this point. This is a nice point because it's what we call the y-intercept. So the value of x is 0. And I'm going to take this one, which we would call our x-intercept, and the value of y is 0. Because I'm going to show you that these are really nice numbers to work with. Again, if I'm looking at these as coordinate points, let's call this point number 2. And I'll call this point number 1. So my rate of change the differences in my y values over the differences in my x values. I get 6,000 divided by 60. That's negative 100. Negative 100 liters per minute. But what does that mean? Well, that means that it's going down. The water level is going down 100 liters per minute. So the negative when I'm dealing with rate of change usually means something is decreasing. It's going down. A positive means it's increasing. It's going up. So when you see a negative rate of change, we know we have a decrease. Now I've changed this title now to section 5.7. I don't know if you noticed that or not. Because what we're doing is we're going to interpret some of this information. So again here we're going to look at the one we just did where our rate of change, do I have a spot for that? Constant rate, my rate of change was equal to negative 100 liters per minute. Question, where does the graph intersect the vertical axis? All right, so let's look at where our vertical axis is. Vertical axis, my y-axis. Where does it intersect? It intersects here at 6,000. What does this point represent? We look back at the word problem. It represents my initial amount. How much is in that tank before I begin? In this case, before I begin to enter it. 6,000 liters. And so my y-intercept is giving me my initial amount. Next question, where does the graph intersect on the horizontal axis? So here's my horizontal axis, and it's intersecting at this point, at 60. What does this point mean? It's in minutes, so 60 minutes. Until when? Until the tank is empty. So when the volume is 0. There's nothing left in our tank. When you look at the initial amount, that means right at the start, at time is 0, how much is there? So that gives us some interpretation upon the word problem. And I talked a little bit about these, so let's look at the horizontal intercept. Horizontal, the point where the graph intersects the horizontal, or what we call the x-axis. That's what our horizontal intercept is. Add to it, it's where the y value is 0. Where my y value is 0. Now let me know what my x value is. So kind of interesting for us. Our vertical intercept, well, very similar. We're saying this is the point where the graph intersects the vertical or the y axis. If we move and kind of take that information that we've just had with the horizontal, put that in with our vertical, it tells me this is where the x value is 0. Where my x value is 0. So that's my horizontal, my vertical, and I kind of explained that in the last example. We're going to look at some more examples to help us. Here is publishing. The graph shows the cost of publishing a school yearbook. The budget for publishing costs is $4,200. What is the maximum number of books that can be printed? So if I want to look at the maximum number of books, I need to find number of books. Now the cost that it said that it could do is 4,200. What? Maybe okay. Oh, so here is 3,500, 4,000. This would be 4,500. I'm sorry, you didn't see my tick marks. That's 4,500. So 4,200 would be in here somewheres, which means we're probably in between these two somewheres. So it looks like 175 books. I'm going to pause for a second. I'll tell you why I just paused, because I'm like thinking this question's a little bit harder than I was anticipating. And I'm like, did they really mean to ask that question, or did I type it down wrong? But it is correct. It is the one from the textbook on page 317. I will modify it and then we'll do the harder one. So if the cost is 4,500, how many books? How many books do we have ordered? Okay, so let's go for the easier question first. So we need to find the cost of 4,500. So I'm looking here at 3,000, and then I have 4,000. Halfway between 3,500. So each block, right, each part of my grid paper on the vertical is going to be 500 books. So that means at this point, I have 4,500. Does it make sense that our points are not connected? Yeah, in a way, like we can't have half of a book. So it's not a continuous graph. Are there more points than are shown here? Yes. So we're going to be doing some estimating. This particular one at 4,500 is going to go across. I have a point. I read the point down, and it says 200 books. So if I'm going to have a cost of 4,500, how many books were ordered? 200 books. I can reverse the questions, and I said, okay, if I had 100 books, what would the cost be? So I'm saying, oh, here's 100 books. Reading up, going over, okay, my cost would be 2,500. We call this interpolating. Interpolating means that we're interpreting the information in the graph. This is when it's between data points. So here I'm looking at numbers that are in my data points that are shown on the graph. That is interpolation. If I then take this information and say, oh, look at this trend, and I say, let's extrapolate from there. It's called extrapolation. It means we're going to look at what is already established. If this trend continues, what would it be? And this would be outside of my data points. Extrapolation. All right, so these are interpolation. What I'm going to now do is the question that this is asking, and it says, what if it is 4,200? So this is slightly different and a little bit more difficult question that's being asked. So we did the easier one. 4,200. Here is 4,500. 4,250 would be halfway, so just below that, about here, 4,200. Hopefully you agree that that's what that would be. Now, if this trend continued, it looks like we have a line. I should probably make it so it has a nice line. And we would agree that it's linear. Even though the dots were not connected, we had linear representation. This would be considered like a line of best fit, and I think you may have done that in science. This is a really nice fit. In other words, it's perfect. Now I'm going to read over on this graph. So we're saying this is about 4,200 till I get to this point on the graph. And then I take that point and I'm going to read down. Oops, slid over. Let's just go a little bit that way. Okay. So I'm taking and I'm reading that number down. So I know that it is over 175. So I might say about 180. Okay, so it's close to about 180. 175 is here. Okay, so maybe about 180. We're going to be guessing. We aren't going to have precision on that because within that block, I can do the 150 and do the 175, but there's 25 points between 175 and 200. And now I'm making my guess as to where it's going to be. Then we're able to say that the maximum number of books that can be printed is about 180 books based on that budget. So we've done some interpolating. We have interpreted our graph. Well, let's see if this one's any easier. And probably not. The graph shows the total cost for a house call by an electrician for up to 6 hours of work. So when they come and when they leave. The electrician charges 190 to complete the job. How many hours did she work? Well, I'm going to change this around. I'm going to ask a couple of questions first. The first question I want to know is, how much for the house call? If they arrive at the door and they say, great to see you, can't help you, and leave, how much is it going to cost you? And how do you know? Well, that cost is right here. Now, if it's 120, 2 steps, how much is it for 1 step? 60. So it's going to cost us $60 just for that house call. That's what that y-intercept is telling me. Right? So the y-intercept, or the what we call the vertical intercept, is extremely important. It's an initial amount. It's kind of like ordering that cheese pizza cost $12 just for the sauce and the cheese. Then additional pricing for each topping. All right, now let's go back to the question that was asked, $190. So kind of think about where we are in our cost. So everything's going up by 60 each block. So this would give me 180. So 190 is just going to be a little bit above it. Maybe not even quite like that, but about there. And then we read down, and we want to know time. Well, more than 3 hours, less than 4 hours. So we might say that here it might be 3.5, the way I have it written. We're making a guess on that. The textbook says, oh, it's closer to 3.25. Right? It depends on how you're drawing. Right? So when I ask a question like this, I will want to see you draw in, and we can base it on that. In the multiple choice, you're going to have one that's the better answer. It'll be quite obvious. Now, we're going to be doing a lot of graphing of lines. And I'm hoping that you can tell with this function that we have a line from what we talked about yesterday. I'm going to show you how I can use my intercepts to do a sketch. So let's start with finding well, the y-intercept is always easy. It's actually the easier one. I recommend that you always start with your y-intercept. When we do any type of a function, this would be the easiest one to do. My y-intercept, I know that x is equal to 0. So what I'm finding is f of 0, and so my y-intercept is 7. Okay, so we'll plot that. It's the point on my y-axis. The x-intercept, that is the point when y is equal to 0. So we're going to say 0 is equal to negative 2x plus 7. Negative 7 is equal to negative 2x. Negative 7 divided by negative 2 is equal to x. What does that tell me? X is equal to 7 over 2. That's 3.5. So we plot that. In the textbook, it says, that's great. You should always have a third point. I doesn't quite say it like that, but it says find another point. So we are between with our x's 0 and 3.5. So let's pick a nice number between 0 and 3. 1 sounds nice to me. And we're going to do the same type of thing. So let me just make this a little smaller. And we're going to find this function for 1. Negative 2 plus 7 gives me 5. That tells me that when x is 1, y is 5. So I plot that point, and I'm going to draw the line. Now, there's a couple of lines here that I can choose from. Someone says blue because my dots are blue. Well, I'm going to pick this red one because it has a double-headed arrow. And when we draw a line, we're saying it's continuing in both directions. So we want to show that with a double-headed arrow. So this is using our intercepts to draw the line. We don't have to do the table of values. If we know it's a line, or even if we don't know if it's a line, if we can deal with this function, find our x and y intercepts, they're going to tell us some information. It's just when you know it's a linear function, it's going to be easy. We'll try another one. So I'm going to give you a chance to try it. You can draw a sketch, find your y-intercept, your x-intercept, and another point. So again, my y-intercept, just to remind you, that is when x is equal to 0. I'm a little bit ahead of my smartboard this evening, so that's telling me that x is 0, y is negative 3. For my x-intercept, remember that's when y is equal to 0. So I get 0 is equal to 4x minus 3. X is equal to 3 over 4. So when y is 0, x is equal to 3/4. Which is right there. And this is not giving me a whole lot of room to find some other points, but I can pick any value of x. Let's take x as 2. So f of 2 is going to give me 4 times 2 subtract 3, 8 subtract 3, 5. There's a third point. Enough now that I can draw the line by connecting my points together. And there's the graph of the line. we'll do is we'll stop there. There are questions, I'm sure, in that section that we can go over, but we'll leave them. You're going to do your assignment. If you are having trouble with any of the questions we've covered so far, why don't you find someone in the class that can help you with it. The assignment is not due tomorrow. Well, this is going to be our review so we can get ready. We're going to need to do a test on the chapter, on the unit, and I think I had said something about that for next week. And I can't remember what day I had said, so just remind me on Thursday. All right. Have a good day, class.